Now we are going to solve previous year GATE and IES questions on turning on of thyristor. This is really important because questions has been repeatedly asked in every 2 or 3 years from this topic. So you need to go through this lecture very carefully. You need to understand all the concepts and to know more about the concept behind these questions. You need to refer my lecture number 6, that is silicon control rectifier. So let's start the video. Now we will solve the question that has been asked in GATE 2006. Okay, here in this question this circuit is given. Okay, and the question says that latching current is equals to 50 milliampere and holding current for this SCR is equals to 40 milliampere. We have to find the minimum gate pulse width required to turn on SCR. Here process is associated with turning on of SCR. That's why this holding current is of no use. So how we can solve this circuit, we see now. Suppose the current through this SCR is IA, that is anode current, and current through this inductor is equals to IL, and current through this resistance is IR. Okay, so here we know that this anode current is simply equals to IL plus IR by applying KCL at this node. So to solve this circuit, to turn on the SCR, what we have to do? We have to make this anode current is equals to latching current, and for this much time we have to apply the gate pulse. So gate pulse width is equals to the time during which this anode current reaches the value latching current. Now after knowing this much concept, we just easily solve this. So first we have to find the inductor current IL. We know that by using concepts of network theory, inductor current at any time t is given as IL infinity plus IL0 minus IL infinity e to the power minus t by tau. Now to solve this, we have to find the value of inductor current at infinity, inductor current at 0, and this value of tau. First, when t tends to 0, we know that initially this inductor is not charged. That's why IL0 negative is equals to IL0 positive, and that is equals to 0. Now at t tends to infinity, what happens? This is DC voltage source, and during steady state this inductor act as short circuit. So when inductor is short circuited and at t tends to infinity, this SCR get turned on, that's why it gets short circuited. So apply KVL in this loop, we get IL infinity is simply equals to 100 by 20, because this is sorted and this is also sorted, so that is equals to 100 by 20, and that is equals to 5 ampere. Now we have calculated IL0, IL infinity. Now what is tau? Tau is simply given by Leq by Req. Now what is inductance? Inductance is only 0.5 Henry. And what is equivalent resistance? See, for t tends to infinity, this SCR is turned on and acting as short circuit. Now we have to find the equivalent resistance across this inductor. Okay, so what is equivalent resistance and how we find it? We simply sort this voltage source to find the equivalent resistance. This is the simple procedure. When we sort this, then this 5 kilo ohm resistance will get bypassed, because this has this sorted branch in parallel. So that's why inductor current, inductor equivalent resistance is simply equals to 20 ohm, because this is sorted, and this makes this 5 kilo ohm resistance bypass, so it is simply equals to 20. So we get 1 by
that is equals to 1 by 40. Now what is 1 upon tau? That is equals to 1 by 40. So simply putting all these things, we get inductor current and at any time t is equals to IL infinity. What is IL infinity? That is 5 plus 0 minus 5 e to the power minus t upon tau. Okay, 1 upon tau is equals to, is equals to 40. 1 upon tau is equals to 40. So minus 40t. Now what is current through this 5 ohm resistance? We know that when a SCR get turned on, then this voltage 100 volt will appear across this resistance. Okay, because they are in parallel. So voltage across this 5 kilo ohm resistance is 100 volt. So that's why current through resistance of 5 kilo ohm is constant and it is equals to 100 by 5000 V upon R, that is 100 by 5000. So now we have calculated inductor current, that is time varying, and resistor current, that is constant. Now what is anode current? Anode current is simply equals to IL plus IR. And what is IL? IL is equals to, simplifying this, 1 minus e to the power minus 40t plus IR. What is IR? That is equals to 100 by 5000. Okay, so on solving this, we get now what is this anode current IA? We know that to turn on the SCR, this anode current must be equals to 50 milliampere. So this must be equals to anode current, and that is equals to 50 into 10 to the power minus 3, or we can write directly as is equals to 50 into 10 to the power minus 3. So on solving this equation, because there is one variable here only, that is time t. So when you solve this equation, you will get t is equals to 150 microsecond. So this is the solution. You must know the concepts only. Okay, after that you can easily solve all the questions related to power electronics, whether the circuit is of this type. Okay, here also in this circuit the concept of two domains are used, that is, one is network theory and another is power electronics. Okay, so you must have the concept of power electronics to understand these types of problems.
If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.